Today we're looking at notes HH-2, polar graphs, roses. So this is part 3 because remember in part 1 we discussed polar graphs, circles, and then in part 2 we discussed polar graphs, cardioids. So this is part 3 where we're talking about roses. So graphs of these forms, r equals a sine b theta or r equals a cosine b theta, where absolute value of b is greater than 1 are called roses. So something we won't really be able to see very well on all the graphs, so I'm just going to tell you for now, is that the a value, whether it be for sine or cosine, represents that petal length. Okay, so I'm going to tell you that before we begin. And then using our calculator, we will graph problems 1 and 5, clearing each one before graphing the next, sketch the graphs, and discuss the characteristics. So before you use your calculator, you'll definitely want to go back to notes HH1 and remember to use all of this to set up the calculator first, okay? Now, I have gone ahead and I have already put in the calculator number 1 because it said to do number 1 first and then number 5. So some things we're looking at. Remember here, we're looking at the number of petals. The petal length I already told you was A, okay? And we will look at that a little closely. It is hard to see on this one because our petals are all slanted. The number of petals, we're going to talk about if B is even, the number of petals is what? So B is even here, so notice B value is 2. How many petals do I have? Well, I have 4. So my assumption would be that if B is even, the number of petals is going to be 2 times B. We're going to verify, of course, but that's what I would say so far. If B is odd, the number of petals is, well, we're going to see that here on number 5 whenever we graph number 5 because B is odd. All of these have a B value that's even, while all of these have a B value that's odd. So we're not there yet. So the sine graphs, petals will open only in, you can see it now on this graph, but we'll definitely see it throughout. For sine graphs, petals will only open in the quadrants. Okay, so they will only open in the quadrants, while cosine graphs, petals will open in, well, we're not there yet. We haven't gotten to cosine. So when we're drawing this rough sketch here, so one thing I do want you to notice, I have 4 petals that are equally dispersed through, so 1, 2, 3. They will happen to be in these like diagonals. 1, 2, 3. Remember that A is my distance, the petal length. So then I'm just going to draw almost like that. Just do your best. Try to make them all about the same size because they should be. But again, do your best, okay? All right, so we are going to do, it said to do 1 and 5, but I'm actually going to keep going on to number 2. So let's look at number 2 next. So I'm turning off number 1, turning on number 2. So this will be interesting. So we would imagine that there will be 8 petals because if B is even, it should be twice B. So 8 petals while the petal length is 2. So cool to watch. I'll never get over it. So we are correct. There are 1, 2, 3, 4, 5, 6, 7, 8. So do notice the spacing between the petals is definitely even. Okay, actually how you find that distance, the spacing, is you take 360 degrees and you divide it by how many petals there are. So in this case, you'd take 360 degrees and divide it by 8 since there are 8 petals. So we're not going to get that too far into it, but it is kind of neat to think about. So what we do know is we need 1, 2, 3, 4 above the x-axis, we need 4 below, and just do your best. So it's going to look something like this, 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 because we know we have 4 equally dispersed on the top there and 4 equally dispersed on the bottom. Your petals are, of course, going to be a little bit thinner. Something like this. So I'm wondering if you're thinking back to the last unit, are our sine graphs still going to be symmetric about the line, the axis pi over 2, and will our cosine graph still be symmetric about the polar axis? Have you thought about that? So let's see. So now we're moving on to cosine. We still have that even b value, but we're moving on to cosine. So I'll graph that one next. Really, really interesting. Okay, so now we're on cosine. So notice the cosine graphs, petals will open on axes first. So notice they were in, all my points per se were in the quadrants before, when now my points are on the axes. So my petal length is 4 units, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And 1, 2, 3, 4. So I had 4 petals because it was an even b value, and we double that b value. So these are kind of thicker petals. So again, like I've said, just do your best. Don't have to be perfect, just don't make it sloppy. Okay, and that's probably about good. They probably should be a little thicker, but that's okay. All right, so now let's look at number 4. So our assumption would be, okay, before I'm going to hit graph, we're going to have 8 petals. Okay, our petal length is 2. We're definitely going to do those axes first. So I would say, is that 2? Yeah, here, 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 and here. But again, remember, it doesn't matter if we're talking sine or cosine. Nonetheless, the petals have to be equidistant from each other, meaning still to find the angle between the 2 petals, you would still take 360 degrees, the degrees in this circle here, and you'll divide it by however many petals. So that'd be 360 degrees divided by 8. Okay, and so that would determine how far apart your petals are from each other. So we're going to graph it and we're going to look. So yeah, we definitely see that the petals on the axes are first, and then equidistant here, 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 and here we have 8 total petals. All right, so now we're going to move on and hopefully be able to fill out this. If B is odd, the number of petals is fill in the blank. Okay, so this is definitely, we want to kind of, definitely a different type of scenario here when we have a B value that is even versus odd. So I'm going to come up here and I'm going to label these length 4 petals. So length, petal length, and then 8 petals. And then petal length, and then 4 petals. And all of these, I'll come back, but all of these had even. B is even. Okay, length, and then 8 petals. Okay, so we're about to find out what happens when B is odd. So, excuse me, on both sine and cosine, the stem is the only petal that touches an axis, okay, or petals. But more specifically, this is for when that B value is odd. So we're gonna go through here. We'll talk about this in a minute. So let's graph this first graph here. So notice we only have 1 petal that touches the axis, and this is going to be true for all of your odd B value graphs. So this is called the stem. So notice when our B value is odd, the number of petals is just B, not 2B. So here we're going to write the petal length is 4, and all we're going to have here is 3 petals. Okay, so I want you to look at that picture really well, and again I want you to notice 1, 2, 3 that your my dots here aren't exactly here. Oh, excuse me, yes they are. They are here on these. I want you to notice no, they are not. I want you to notice that your petals are still evenly spaced. Sorry, y'all, I had to think that one through, because that would mean if I put those here, I want you to know what I was thinking about. If I put those dots here, those are like your quote-unquote 45 degrees, and these two petals would be 90 degrees away from each other spaced, but then this and this would be way more than 90 degrees, and that can't be. That can't be because the petals, like I've said a couple of times now, have to be evenly spaced. Okay, so these dots cannot be up here at the 45 points because the petals have to be equidistant from each other. So I knew that. When I thought it through, I was like, nope, can't be. Okay, so let's look at number 6 now. I told you it's not going to be an exact science. You're just going to have to do your best. And if you want to know exactly how far apart they are from each other, remember, you can take 360 degrees and divide it by how many petals you have. Okay, so let's look at, enough of that talk. Let's look at the next problem. So number 6. So on number 6, as we imagined, our petal length is 3 units. So you count up, you can see that petal length is 3 units. You can see on the quote-unquote stem that's on our axis here. Okay, and then we have 5 petals. Notice they are evenly spaced out. So we do have this one stem, 1, 2, 3 here, and then the rest are going to be about there, about here, about here, about here. Okay, so it pretty much makes a pentagon before you draw the petals. And like I said, it's not perfect, but we do our best. Okay, and it's like kind of like a starfish. So, and what do you know, that color almost looks like a starfish color. Okay, so do your best there, and that's about what that one looks like. So now we're going to hypothesize with this one, length here, 7 petals. Okay, and did you notice that the stem on this one was down, the stem on this one was up? I'm going to hypothesize that the stem on this one is down because we go 3, 5, 7. And then from there, of course, all of our other petals will be evenly dispersed. So this one's 2 sine 7 theta. And of course, eventually we won't need the calculator, but we're just kind of learning right now. So notice we do have this petal down here, and then we're going to have petals about here, here, here. These are 360, 51 degrees apart, so about here, 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 and here. Okay, so it really makes that almost octagon stop sign shape. Oops, that one kind of got too fat, didn't it? Too thick of a petal. Okay, so now this is, so first we're going to say right here, when B is odd. So when B is odd on both the sine and cosine graph, the stem is the only petal that touches an axis. Now that's only when it's odd. You notice whenever B was even, okay, like for example on this one we had multiple petals, all 4 petals that were on an axis. But when B is odd, we only have one, called the stem, one petal that lies on an axis. So, and furthermore, we're going to further this. I'm going to change this color. I think I would rather this be in purple. So sorry. When B is even. Okay, so when B is odd, so notice for sine, these were all sine, not cosine. For sine, the stem alternates up and down. That's an and sign. Goodness gracious. Okay, so for example, when B equals 1, we actually have a circle, and the stem is up, the quote-unquote stem. Okay, but when B is 2, odd, hello, when B was 3, 5, and 7, so for 3, that's when we had this shape, right over here, that Y shape, the stem was down. And then when B was 5, the stem was up. And then when B was 7, the stem was down. Okay, so now we're going to look at your cosine graph. So again, this is going to be our length. We're going to say 3 petals here. This is our petal length. We're going to say 5 petals here. Remember, the reason we have the amount of petals as is the B value is because the B values are odd. So length and then 7 petals. Okay, so number 8. Now we're shifting gears to cosine 3 theta. So we're going to graph and notice 1, 2, 3. Our stem is here on the right here on the right. So sorry, I'm trying to do like more than 2. What am I doing? This should be 2. I'm trying to do too many things at once here. Okay, so notice our stem is on the right. Notice we have 3 petals. Notice our petal length is 2. Okay, I'm trying to speed it up. And then this will be 4 cosine 5 theta. We're going to graph that guy. So notice again, 1, 2, 3, 4 is our length. Our stem is on the right. Okay, from there we're about 1, 2, 3, 4. Here, about here, about 1, 2, 3, 4. Definitely here, 1, 2, 3, 4. I didn't go 4 on that one. So you definitely want to make that pentagon type shape, but it is kind of sideways. Remember, just doing our best. So then we have next, our last one, y equals 3 cosine 7 theta. All right, so 1, 2, 3. Our stem is still here on the right. Then we're going to have about here, about here. Here, I think that one's probably a little lower. Here. Maybe here. And then here. So another thing I want you to notice that I asked you about earlier is something that can definitely help you other than the spacing. So knowing here, if you really wanted to find about the degrees that were in between each petal, remember you'd take that 360 and divide it by 7, the number of petals, okay? But also, remember, your cosine graphs should be symmetric about this polar axis, and are they? They sure have been. While your sine graphs should be symmetric about this pi over 2 axis, and they definitely have been. So use that knowledge to help you graph. So last few things I'm going to summarize here. For cosine, and again, remember, this is all for when b is odd. When b is odd, okay? For cosine, the stem, so the only petal on one of the axes is to the right. And that's because all of these a values are positive. If the a values were negative, when a value positive. If a were negative, I bet you could imagine that that stem would be on the left. All right, I think that about summarizes it for today.